Our next section is acid-base disturbances, alkalosis. Now remember, metabolic alkalosis. Anytime you have a serum bicarbonate that's increased, there is a metabolic alkalosis. Every time the serum bicarb is increased, you have a metabolic alkalosis. Every time you have a serum bicarb increased, it's an alkalosis. Every time you have a bicarb increased, metabolic. Now what we know is, you see this? All the things that are going to cause you to have a metabolic alkalosis, the same way, if you give bicarbonate, you could drive potassium into cells, and alkalosis causes hypokalemia. On the other hand, hypokalemia can cause an alkalosis. Why? Because potassiums must come out of the cell, and hydrogen ions gets driven inside the cell. The same way, when you give exogenous steroids, steroids have aldosterone-like capacity. So the aldosterone-like capacity of those exogenous steroids drives the potassium to be lost and hydrogen ions to be lost. GI loss is this: the colon excretes acid. So when you have diarrhea, your colon becomes an acid-excreting organ. Now, decreased chloride intake is because when you have a decreased chloride intake leads to an increased bicarb absorption. Because chloride is an anion, bicarb is an anion, and when you don't have chloride around, you increase the bicarbonate absorption. Contraction alkalosis. Every time you have a bodily contraction of volume, like from a diuretic, you get an alkalosis. Well, why? Because when you have a bodily contraction of volume, you get an increased renin. And when you get an increased renin, you get an increased angiotensin 1, angiotensin 2, and angiotensin 2 increases aldosterone. So when you see contraction alkalosis, it's really saying aldosterone. Aldosterone makes you retain sodium and excrete hydrogen ions. Now, milk alkali syndrome, before there was omeprazole, lansoprazole, pantoprazole, esomeprazole, rabeprazole, there were H2 blockers. And before there were H2 blockers, what do we have? Maalox, Mylanta, Rolaids, Tums, antacids. So milk alkali rightfully belongs down at the bottom here, because milk alkali syndrome would be basically a person who's drinking a bottle a day of Maalox and is taking all that bicarb into themselves. Potassium, when it comes out of the cell, because I don't want to die of an arrhythmia, remember that if you have a low potassium, potassium comes out of the cell. But what goes in to maintain electrical neutrality? Hydrogen ions get sucked into the cell. So that means hypokalemia can lead to an alkalosis. And alkalosis can lead to a hypokalemia. Now, a respiratory alkalosis, you see this list here? This is basically saying 27 different ways of hyperventilation with a decrease in my PCO2. So anemia makes you hyperventilate. Pulmonary embolus makes you hyperventilate. You see, all of these is really saying hyperventilation. Progesterone, for a reason that we don't understand, directly stimulates your brainstem to make you breathe. Did you know that? Did you know that the progesterone tickles your brainstem? I didn't know that. Well, actually, I guess I did. Salicylates also directly stimulate your brainstem to make you breathe fast. Now, for acidosis, this is the anion gap. The anion gap for an acidosis, is really saying the cations, cats, right? The cations, minus the anions, which is chloride and bicarb. Well, the only two acidoses with a normal anion gap is diarrhea and renal tubular acidosis. So if you have an increased anion gap is mostly there's something that's been put into you that wasn't there before. Something's been put into you that wasn't there before. Alcohol, methanol, ethanol, ethylene glycol. A normal anion gap is you're losing something. Diarrhea and RTA, I'm losing bicarbonate. But an elevated anion gap, lactate. Lactic acid is something that's now in you that wasn't there before. All the lactates in the world, increased anion gap. This basically means that you are having an increase in your amount of lactate because you have hypovolemia, hypotension, some form of shock, hypovolemic shock, hypotensive shock, some form of shock. Methanol and ethanol and ethylene glycol, methanol and ethanol and ethylene glycol. If you see these, even uremia. Uremia is a failure to excrete native acids made as a metabolic breakdown product of your own muscles. It's something that's been put into you that shouldn't exist. Now, it may be built up of your own waste products, but this doesn't exist in that much in you normally. For instance, in DKA, acetoacetate and beta-hydroxybutyrate are two things that should not be in you in abnormal amounts. There's something extra been put into you. Since they are something extra that's put into you, what happens is that the gap goes up because you basically have a decrease in the chloride and a decrease in your bicarb. Because what you're having in exchange, you're having an increase in your lactate. But we're not measuring the lactate. We're measuring these bad boys. You have an increase in salicylic acid, which drops these two. But salicylic acid is not measured. We're measuring these two. You have an increase in methanol, ethanol, ethylene glycol, which increases all of these extra unmeasured anions. So it drops down the chloride and the bicarb. So what happens is, when you have extra lactate, extra aspirin, extra methanol and ethanol and ethylene glycol, these are all going up and these anions are getting lost. But these are the anions we're measuring. So it looks like the sodium minus these, that the level is increasing. The difference is increasing. That's the anion gap. You have breakdown products, acetoacetate, beta-hydroxybutyrate, driving these down. Lactate, driving these down. Salicylic acid, driving these down. Increased anion gap metabolic acidosis. Normal anion gap metabolic acidosis. RTA and diarrhea. What can distinguish them? The urinary anion gap. Respiratory acidosis is really 10 different ways of saying hypoventilation. Can you name me all the things that cause an increase in your PCO2? I don't ventilate, 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 I don't ventilate. Increase in your PCO2 causing you to have a rise in PCO2 and a respiratory acidosis. Acid base is very complex to people because look at this last thing about respiratory acidosis. 10 different ways of saying the same thing, increasing the PCO2. So what this means is that you should do some problems of solving blood gases so that you can practice. So what do you do now is what you're going to do is you're going to study for the next month or 2 months or 3 months, depending on when you have to take your test. And then the month before your exam, all you're going to do is questions. Because those questions are going to allow you to know what things you missed in your studying. The questions are like a gallium scan for ignorance. They're going to allow you to know what you missed that you should have studied. So study in general now, and only problems in the 4 to 6 weeks before the test. And I'll see you somewhere along the line.